The problem statement that I have taken for this particular assignment is the change problem, which is used in a lot of interview questions as well as hackathon. So here the problem statement is that given a set of coin denominations and a particular amount, we have to realize this amount. We're using the more least number of coins, which is given in this particular array. So this particular problem statement, it can be solved using two kinds of approach. The first one, which is the brute force approach, is the most obvious one, which is basically the usual trial and error method, wherein we iterate through a huge number of conditions and we finally end up with a result. But obviously, it would help end up with a huge amount of code, as well as it takes a lot of time to process, and also it does not work for a few cases as well. So hence we'll be using a second kind of approach, which is the dynamic programming approach, which is basically binary, wherein we take a complex problem statement and we divide it into certain subproblems, and finally we combine all those intermediate results and come up with a result. So we're using the same uh, idea over here, wherein we will be using the dynamic programming array, wherein we will be, for certain for this particular amount, or this particular for this particular amount, what is the minimum number of coins required. So we'll be calculating that for each array element by utilizing the previous element's value as well, so that we won't have to iterate completely from the start. So this is what is the dynamic programming array which we are using in our case. So as I said, the problem statement will be containing the particular amount as well as the array of the coins of per- certain denominations which is given to us, and we have to use these coins and add up to this particular amount, and we basically have to find out the minimum number of coins which is required. So here in this dynamic programming array, what we are doing is we are assigning its size from 0 to that particular amount, which is 11 in this particular example that I have taken. So what we do is we fill up each of these array elements, and finally we'll be taking this particular result as our value, which is the required end result. So why we have to do this entire array is because for say for example, if I have to get the value of 10, I can use this previous result to calculate this value. So that is the whole idea of using a dynamic programming array. So that's the base logic. So let us first see how this works with a few examples, and then we will move on with the coding part. So say, as I said, it starts from 0 to the particular amount, which is 11 in my case. So if we take the amount to be 0, the obviously the number of coins required is again 0. So skipping that. And if we take the next value, which is 1, so the amount to make is 1. The coin choice here in this case, we cannot use 5, 6 or 9 obviously because they are greater than 1. So we take just 1, remainder will be 1 minus 1, which is 0. So which means the number of coins required in this case is 1. Now moving on to the next exam amount, which is 2. So here again the amount to make is 2. The coin choice is again we cannot use 5, 6 and 9 because they are greater than 2. So we just take 1, and the remainder will be 2 minus 1, which is we are left with 1. So as we can see from the previous array element, the minimum number of coins needed to make the amount 1 is 1. So which means that I will end up with 1 plus 1, which is 2 coins, which is required to make up the amount 2. And so it just continues all the way until the last element. Okay, so but also we can have certain options. Say for example, if we take this example 5, we cannot use 6 and 9 again because they're greater than 5, but we can use either 1 or 5. So in this case we'll be having two cases. Case 1, if we utilize 1 coin of denomination 1, and case 2, if we utilize coin of denomination 5. So we take case 1, the amount to make is 5. Coin choice is I'm taking it as 1. Reminder is 5 minus 1, which is 4. So the amount or minimum number of coins required to make up this amount 4 will be actually 4 from if we calculate all the way up till 4. So which means that I will be requiring 5 coins in my case 1. So if I take case 2, which is coin of denomination 5, amount to make is 5, coin choice is 5, and reminder will be 0. So the minimum number of coins required is just 1. So in my case 1, I need 5 coins, and in case 2, I need just 1 coin. So as the problem statement states, I need just the minimum number of coins required to make up that particular amount. So out of 5 and 1, 1 is lesser, which is the minimum. So that's why the minimum number of coins required to make up the amount 5 is 1. And so on and so forth. This whole dynamic programming array will be filled, and finally we'll be taking this as the end result as said before. So with this logic in mind, if we move on to the code over here, so here we are utilizing these two libraries. This library, as we know, it is used for taking input and output functions, and then this library limits, we are utilizing it to take this value int max, which basically gives us the maximum integer value which can be taken. So we will see why we are utilizing that in this statement. Now we are defining the function over here before we are choosing the main function. So this function, which I'm naming it as coin change, it contains these particular parameters. So the coins array is basically, in my case, the coins of these certain denominations which are given. And next one is the number of coins, which is basically in my case, which is 1, 2, and 3. And then the amount, that is the particular amount which has to be realized using these particular coins, which in this example is 11. Again, these two can be taken in as input using a scanf statement and a for loop, but for the simplicity of this code, I'm just taking this particular example over here. Now, we are we are going to fill up the dynamic programming array and then end up and then for return this particular thing at the end of the function so that we can get our result over here. So we can have three cases. Okay, so one is that if the amount is lesser than 1. If the amount is lesser than 1, we cannot realize it using any sort of coins at all. So we'll be returning that as 0. And if in certain cases, if uh, that particular amount cannot be realized using any sort of combination of my coins in this particular array, at that time I have to return that as -1. So that is why we have this particular conditional statement at the end of this function, wherein using this conditional statement of using this particular operator, if at all I am unable to realize my amount using that particular coins in this array, in that case I will be returning it as -1, or else I will be returning the result at the end of this loop. We'll be seeing how this loop works. So first of all, I'm going to again uh, will assign my or initialize my array, which is minimum coin dp, which is the dynamic programming array, as I have mentioned before in the logic. It has to run from, again, as in this case, if it's 11, it has to go from 0 to 11. Since an array starts from 0, so if we give just 11 over here, it will just array will be given only from 0 to 10. So that's why we are giving the array size as amount plus 1. Okay, so this is the nested for loop that we are utilizing over here to fill up all the elements in the dynamic programming array. So this is the nested for loop, as I said before. So this first outer for loop. So what it does is it basically iterates to the entire array and assigns each of those elements as int max, which is maximum integer possible. Basically, we're just assigning all of these elements as some particular, default value before they are changed into any of the end results by this particular loop. So if at all we are unable to, if at all we are unable to realize any of these particular amounts using the coins of this particular denomination, it will just remain as int max. It will not be changed using the next for loop at all. So that's why, so then at the last we can use the conditional statement to return the value as -1. So that's why we're using this assigning each element value as int of max. So now going on to the next inner for loop, what we're doing is we are iterating to this coins array, this coins array. So what we are doing is the first this for loop statement, we are iterating to this particular coins array where we are checking what and all coins, denomination of coins are present over here. Now after that, we are using only full of conditional statements over here, if statement. So the first conditional statement, what we are checking is we are using an AND operator in this conditional statement. An AND operator is wherein only if and only all both of the conditions are satisfied, then this whole if condition will be satisfied, will be true. So let's see what the first condition is. The first condition is that coin j element in the coin array should be lesser than or equal to I. As I had mentioned before, say for example, if we take the amount 2, which we can only use the coin 1, not 5, 6, and 9 because they're greater than 2. That's what it basically is. Say for coin element j, it should be lesser than or equal to I, which is any of these amount. So that's what the first condition is. Second condition is that the second condition is that the previous element, array element, should not be equal to int of max. So the only case int of max remains is when that particular amount cannot be realized by coin of any denomination in this particular array. So say for example, just for an instance, if phi is not cannot be realized using any of the elements in the coins array, so it will just remain as int of max. So which means that if we move on to the next element, which is 6, so we have to use the result of the previous array element to calculate this array element, right? So if this is in max, we cannot calculate this particular value. So that's why we're utilizing the condition that this previous element should not be equal to int of max. So if both of these conditions are true, then this if condition will be true, then which it will execute the rest of this condition. So under that if statement, we are again having another if statement. So this is basically an example of a nested if. So if that particular element which I am looking into right now, if it is greater than 1 plus the previous element, that is basically, as I said before, this if I'm calculating for this element, it will be 1 plus the result of this previous element, right? So if it is greater, so obviously it will be equal to this one. So that is what we are checking in this one. So it will be, if that condition is satisfied, that value of 3 will be equal to 1 plus the previous value. So with this, this entire loop gets terminated, not terminated. That is what is the whole logic of this loop. And at the end of the function, we can return the value as either -1 or the actual result, depending on whether the particular array element is equal to int max or not. So here the amount, as I had taken over here, it is equal to 11. So if we take the array element 11, so it can be, if it cannot be realized by any of these coin denominations, then it will remain as int of max, or else it will have some particular definite value. So that is what we are checking using this particular conditional statement, which is similar to an if statement, but is not uh, it's similar to an if else statement, but it uses a different operators over here. So if that particular array element is equal to int of max, it returns -1. If not, it returns the particular array value which is printed over there. So that will be the end of the particular whole function over here. So now we are going to call this function and the main function. So the main function we are assigning it as n, so which means that we have to terminate it using return 0. So here we are assigning the coins array as well as the amount, as which I has mentioned before. It can be taken in as input using scanf and for loop. And here we are assigning the value of the particular function into a particular variable called as result. And finally, with the printf statement, I'm printing my result in a proper way over here. So that will be the end of this code, which is to basically find out the minimum number of coins required to realize this particular amount given the number of coins in a particular array.